Distinguished guests, ladies and gentlemen, good morning, good afternoon, and good evening. Welcome you all to join in 2025 International Online Seminar towards mainstreaming bamboo construction, research, and practice. The seminar is joint organized by INBAR Bamboo Construction Task Force and Rattan, International Union of Laboratories and experts in construction materials, systems, and structures. My name is Liu Kewei, the Global Bamboo Construction Program Coordinator of INBAR, as well as the Coordinator of INBAR Bamboo Construction Task Force. It's my great pleasure to welcome you all to join in this learning journey. Dr. Edwin Zen Escamilla will chair this session with me. First of all, let me introduce our distinguished speakers. When I call your name, you can open your microphone and say hello to everybody. Durai Jayaraman, Director of Global Program at INBAR.
Thank you, all of you.
Thank you, Durai. Luisa Molari, Co-Chair of Rattan, TC322. Mechanical characterization on bamboo, and she is also an associate professor at the University of Bologna. Luisa?
Yes, hello to everybody.
I welcome you to join us. Next, let's welcome Edwin Zen Escamilla, Chair of INBAR Bamboo Construction Task Force, the Senior Research Associate at the University of Applied Sciences and Arts, Northwestern Switzerland. Hello, Edwin.
Thank you very much, and hello to everyone.
Okay, let's welcome Gabriel Smith, Project Manager at EcoInvent.
Hello, everyone. Thank you so much for having me. It's a pleasure to be here.
Thank you. Let's welcome Hector Archela, Senior Lecturer at the School of Architecture and Environment. He is from University of the West of England.
Thank you, Kiwei, and welcome, everyone. Thank you very much for the invite again.
Thank you. Let's welcome Luis Felipe, General Manager at Space Bahia Foundation.
Thank you, Kiwei. So, hello, everyone.
I will also have the honor to deliver a presentation to you all today. So for today's agenda, we will begin with opening remarks, followed by the release of a new video and a new book. And then could you please mute your microphone? And then 3 presentations on the life cycle analysis of bamboo building materials and buildings. Let's welcome Mr. Durai Jayaraman to deliver his speech.
For the introduction, His Excellencies, distinguished participants, ladies and gentlemen. So, listen, good morning, good afternoon.
Durai, your voice is very low.
Is it clear now?
No, can you louder?
Yes. Is it clear now or no?
No, it's very low.
Okay.
It's fine for me.
Okay.
Okay, fine. So it's an honor for me, and it is a delight to deliver the opening remarks on this online event titled International Online Seminar Towards Mainstreaming Bamboo Construction Research and Practice. As you know, bamboo is traditionally being used as a construction material across tropical and some subtropical regions of the world. The research and innovations in the past decades have enabled the bamboo's usage as a contemporary construction material in its original form as well as in engineered forms. With the development of the modern construction technologies, the use of bamboo in architecture has gradually developed from small sized, like some vernacular structures, to the construction of large sized infrastructure and like some public building. So since the pandemic, it is already like some 6th year for us to have an online seminar on the bamboo construction. So continuing on the greater impact of INBAR's online webinar seminar on the bamboo construction in the past years, this year's seminar will highlight both the scientific advances and practical pathways towards the wider adoption of bamboo in the built spaces, and particularly focusing on the LCA of the bamboo building materials and buildings, scalable models and practices on bamboo constructions, and also INBAR, like ILM's joint session, development in the characterization and application of the bamboo material and engineering with bamboo from laboratory test to the building code. So these are all the 4 sessions like some we will have. By hosting this online conference or the seminar, we ensure the broader accessibility and encourage participation from the global audience, including students, researchers, industry professionals, and other key stakeholders. This inclusive platform will foster a comprehensive dialogue on technological advancement and the research breakthroughs to mainstream bamboo as a sustainable construction material. So over the course of this 4 sessions, 12 speakers from across the world, from Canada, China, Colombia, Germany, India, Indonesia, Philippines, Switzerland, and the United Kingdom will deliver presentations. Several INBAR staffs and INBAR construction task force, like some members, are going to chair and join in the discussion in the different sessions. In conclusion, a seminar will be a valuable and informative experience for all of us. So let us make the most out of these opportunities and take away something new. And finally, a big thank you for our organizing committee for putting this seminar together and for all the hard work that went into it. I wish all the very best for all the participants and speakers. Thank you very much. So, like, who are muted, please unmute.
Thank you, Dirai. As Dirai mentioned, we have been organizing this event for 6 years. So we sincerely appreciate the ongoing support from all of you from across the world. Now let's welcome Professor Luisa Molari to deliver her remarks on behalf of Rattan TC 322. Welcome.
Thank you, Kwei. Yeah, I'm gonna spend just a few words about RILEM and about the new committee on the mechanical characterization of bamboo. RILEM, as Kwei already anticipated, stands for French words meaning International Union of Laboratories and Experts in Construction Material System and Structures. It was founded in 1947 with the goal of promoting international cooperation, encouraging innovation in research, and supporting its practical application in constructions. And RILEM also aims to advance the sustainability in the field of construction. RILEM's work is carried out through technical committees, which are groups of international experts collaborating on specific topics. And our committee is the TC 322, is on the mechanical characterization of bamboo, is chaired by Professor Kent Harris and co-chaired by me. And we currently have 5 active working groups, one focusing on mechanical testing, one on durability, one on sustainability, and we have also two new groups, one focusing on connections and one looking into existing buildings and what can be learned from their performance over decades. And our first tasks include publishing a state-of-the-art report early next year, covering all the topics addressed by the first three working groups, and a glossary on bamboo terminology that is already available online. And we are also setting up a worldwide database on bamboo, which will serve as a reference for researchers and practitioners. Future activities will include round-robin tests, grading, and quantification of durability and sustainability, all with a long-term goal of contributing to future standardizations and in the field of course, of bamboo construction. So concluding, we warmly invite anyone interested in bamboo research on or application to join us and contribute to the work of the technical committee. And for all the information about the committee, you can go to the RILEM website, that is www.rilem, that is RILEM.org. So everyone really welcome to join us.
So thank you, Luisa, for your promotion of RILEM.
Yeah.
So we are excited to co-host the joint session 3 with you and Ken Harris, as well as another 3 young experts. And so next, let's welcome Dr. Edwin Zeng Escamilla to deliver his opening speech.
Thank you, Kevei. As it was mentioned, I'm the chair of the Task Force on Bamboo Construction from INBAR and one of the persons responsible behind the organization of this seminar. It's important to me to remark the focus we have this year on mainstreaming bamboo construction, and as Luisa mentioned, the initiation of the technical committee in RILEM was one big step. And something we should mention is that since this year also RILEM and INBAR are in a partnership, which is another step where we bring bamboo to the big stage. Is no longer an alternative material, is a material in its own right. And with that, I want to thank you all for attending today, and especially to all the speakers for joining us and sharing your time and expertise with us. And with this, I hereby open this online seminar 2025.
Thank you, Edwin. This is Edwin's final year as chair of INBAR Construction Task Force. So we deeply appreciate his tremendous contribution to this group, especially to promote the research on life cycle assessment for bamboo materials, as well as other contributions. So next, let's welcome Hector Achela to introduce the first video produced by INBAR Bamboo Construction Task Force, learning about bamboo reinforced concrete, yes or no. So Hector, the floor is yours.
I don't know why my microphone goes off, but anyway. So yeah, what I wanted to say is this is part of the work that we do with the bamboo construction task force with INBAR. And this is part of the research that many of us in the task force have been doing. So some of the names that you see in that paper, you can scan the QR code and go into the paper to get more details of that research. And I think the important thing to say, and let me see if these slides work, is so the main conclusions that we got from studying work in practice and the research that we have done is that bamboo reinforced concrete is an ill-conceived practice. So it's something that we shouldn't be doing. Something that many promote on social media and on papers, but they do fail to address the main problems regarding strength, stiffness, durability. And as we demonstrated in this paper, even though you're using bamboo, if you want to make it safe, if you want to make it, built properly, it is not an environmentally friendly alternative because you end up using more concrete. It's not safe, and you need some treatments for the bamboo not to crack inside concrete. So it's probably a call to action to everyone in all the participants of this event and all the people using bamboo to stop using bamboo reinforced concrete. But yeah, as I said, more details are available on that paper, and the video will go live, I guess, on social media and other networks that INBAR has. So that's it for me.
Okay, thank you. I believe Hector and Jan will produce more videos in coming years. And so following the video, we will have a new book release, Bamboo Construction Manual for Single-Story Housing, produced by INBAR and the Base Bahia Foundation. So let's invite Luis Felipe to introduce it.
Hello, everyone. So thank you very much, Kewei. Can you see my screen now?
Yes.
Okay. So as Kewei was announcing, we are very happy to share with all of you the new manual for construction of single-story houses made of composite shear walls. This is a collaboration between Base Baha'i, INBAR, the Construction Task Force, and of course supported by the Hilti Foundation. We have been working on this for the last 2 years. A lot of work has been done to make this manual possible, and you can see here the content. It discusses about the bamboo as a construction material, the pre-construction requirements of a composite bamboo shear wall house, the construction process, reference materials and standards, and some annexes. I will show you a little bit about the content in the bamboo as a construction material, the chapter 1. We present the different species around the world, and we present also what is available and the main continents and the main countries, but also what are the threats of natural disasters in each region and how we can address them with bamboo. In the chapter 2, we present the pre-construction requirements of a CBFW house, and this talk a little bit about the treatment, the harvesting process, the grading of the bamboo, the classification of the poles for construction. And then we have an extensive chapter of how to build a proper house, step by step, starting from the foundation of the house, the prefabrication of the walls, the installation of the components, the roofing components, and the finishes of the house. It's a very detailed and comprehensive material that will allow many people around the world to build their own houses. And at the end, in the annexes, we introduce a detailed house project that everyone can follow in their own countries, including the details for construction and foundation, and the prefabrication of the walls. It's a simple house that can be replicated, but also just a simple example to understand how easy it is to replicate this material. So this is just recognition of the people involved. Thank you to our team in INBAR and the team of Base Baha'i that works very hard. We have also more collaborators that participate in this. A lot of people get involved, but these are the main people. And finally, for all of you, the manual is already in the website of INBAR as well in the website of Base Baha'i. It's totally free. You can download, you can share. Please make this viral and everyone can use it. You can scan the QR code now and then start to enjoy the manual. So thank you, INBAR, and thank you everyone that participated in this, and I hope you can enjoy this manual.
So thank you, Luis Felipe. It's really a fantastic book. We sincerely appreciate the efforts made by our colleagues, as Luis Felipe showed on the screen. So my colleague, Ms. Liu Qinghui, already typed the link in the chat box. You can download it from INBAR's website. So for the next session of presentations, I will hand over to my colleague, Edwin, to chair. So Edwin, the floor is yours now.
Thank you, Kevin. Thank you very much. Okay, so we now go to the core of our session today. And as it was mentioned, we will have three presentations all around life cycle assessment of bamboo materials and buildings in general. And we will start with a presentation from Dr. Gabriel Smith from EcoInvent. EcoInvent is the largest and most reliable, I would say, database of life cycle inventories around the world. Is based in Switzerland, but has a global reach. Gabriel manages forestry and pulp and paper sector at EcoInvent, and we holds a PhD of forestry ecology from Stanford University. Once again, Gabriel, thank you very much for accepting our invitation and for your time today and sharing your knowledge and experience working at EcoInvent. The floor is yours, Gabriel, please.
Thank you so much, Edwin. I'll just share my screen and then we can get started.
While we get the screen done, we will have a very short time after each presentation for questions, and we hope at the end of the seminar the speakers can still wait for us, and we will have a Q&A session at the end. All right. Thank you, Gabriel. Please go ahead.
Okay, so does everyone see the screen, the sort of sepia-toned picture of the highway? Are we good?
Yes.
Great.
Good.
Okay. So as Edwin said, I'm Gabriel. I'm a sector manager at EcoInvent, specifically for the forest and wood sectors. And this presentation is going to be about bio-based materials in the EcoInvent Lifecycle Inventory database. So I know that this is a broad audience, and so I want to first answer the most basic question, and that is, what is life cycle assessment? And more specifically, why should you care about life cycle assessment? To answer this question, what is life cycle assessment? Life cycle assessment is a quantitative way to translate the recipe for a product into a comprehensive measure of its environmental impact. And so this will allow us to take a huge amount of information about the ingredients and sources for a given product. That's called a life cycle inventory. And then we can transform that into a number that can easily be compared with other products. And if we're thoughtful about the methodology, we can then come to conclusions about how sustainable the product is by comparing it to others. We can also identify what parts of the product contribute the most to its environmental impacts. And so the fact that life cycle assessment makes this possible directly answers our second question, actually, which is why should we care? We should care because life cycle assessment is the primary way that a company is going to assess the environmental impact of its products and services. And so if a company values sustainability and wants to base their decision making on something more than just a gut feeling, they will probably pay somebody to assemble a life cycle inventory and then do a life cycle assessment, or they're going to do it themselves in-house. And then their choices going forward are going to be shaped by the results of that life cycle assessment. There are a few other uses as well, like meeting regulatory requirements, but for now we'll focus on this one. And to illustrate, let's do a thought experiment. Let's say that you are a company and you're comparing two different potential recipes for a cutting board. You could make the board out of oak wood, or you could make it out of bamboo. And to measure which choice is more sustainable, you will probably hire somebody to do an LCA, a life cycle assessment, for you. And this person is going to compile a list of all of the inputs for each cutting board recipe, and then use a background database like EcoInvent to turn that list of inputs into a measure of environmental impacts. So what is EcoInvent? I just said we're a background database, and I think Edwin mentioned this as well. But what does it mean, background database? It means that we provide a huge collection of high-quality data sets that are intended to cover just about all the raw material and processing inputs for most any kind of end product. And for an end product, you might know what kinds of material you need to have at your factory to enable production, but maybe you don't know everything about where those materials came from. You might not know the environmental impacts of the electricity that the factory uses, or the mining that's necessary for metals that the product relies on. And so for this kind of thing, you need information about the background of the product. And for this, a background inventory database like ours is essential. And so in the example of our hypothetical cutting board that uses perhaps a kilogram of bamboo or a kilogram of oak, EcoInvent will provide the background that tells us what that kilogram of oak or bamboo means when it comes to things like carbon emissions or water use. So here's an example of one of these data sets, which actually your colleague Edwin provided. And so because Edwin assembled this data set and then worked with us to publish it, someone who wants to include Chinese bamboo in a life cycle inventory can do so. And they're then going to know exactly how much water, carbon, fertilizer, etc. is associated with each kilogram of bamboo they use. And because the dataset is published in EcoInvent, they know that it has undergone rigorous quality checks and review, so they can trust the information that it contains. If there were no dataset to use, they would just be guessing, and they might get it wrong. So if you want people to know that your material is more sustainable than a potential alternative, then submitting data to EcoInvent is a very good idea. The people who are trying to make their products more sustainable are using EcoInvent to compare different potential material sources. So let's dig in a little bit for bio-based materials like bamboo. Bio-based means this is something that grew and then was harvested and processed. So agricultural crops and trees would also be examples. This is in contrast to something that has to be mined, like copper or iron. And when it comes to evaluating the impact of a bio-based material, there are some unique considerations because the product itself contains carbon that was absorbed from the air and then turned into biomass. The way we handle this in EcoInvent is that the basic ingredients of carbon, energy, and water are represented as elementary flows. So this represents the growth and the photosynthesis of the plant as it builds biomass. And in this example, it's the bamboo plant. And currently the water is contained within a wood flow, though we might change that in the future and represent it as an elemental flow by itself. So these elementary flow inputs are then linked by plant growth to the bamboo culm output product. And we call that a technosphere flow because it was created by this process. And it's not just a part of the environment, though of course bamboo can also grow naturally. But because it's the main product that comes out of the bamboo forestry dataset, we also call it a reference product. The bamboo culm has properties, that's these boxes, And these properties describe the elements that it contains. And to the extent that the bamboo culm represents the entirety of the plant growth that happened here, these should all balance. For the bamboo culm reference product, let's zoom in and see what those properties look like. These properties tell us how much of this kilogram of bamboo is water, how much of it is carbon, what its price per kilogram would be in units of 2005 euros, and also even how much energy it would generate if you were to set it on fire. And so on the subject of setting bamboo culm on fire, if at the end of its life a bamboo or a bio-based product is combusted or otherwise degraded, the carbon that it contains is going to be released again as an emission. This will be another elemental flow. And of course, this bamboo forestry data set does not involve burning all of the bamboo culm that was produced at the end. That would be very silly. But if it did, this is what it would look like. And at the level of a single EcoInvent dataset, all of these input and output flows should be balanced. But across a whole supply chain, where we have multiple datasets connected to one another, things can become more complicated. So what does a supply chain made of multiple activities look like? In this case, bamboo culm from the bamboo forestry activity ends up in the production of bamboo pole. But this industrial activity takes a lot more than just bamboo culm to do its work. Among other things, it needs electricity, and it also produces wastes, these bamboo residues. Finally, just like the bamboo forestry dataset, it has a reference product output, in this case, bamboo pole. And when we have multiple interlinked activities like this, we can assemble a whole supply chain that then terminates in the product that a company or a sustainability consultant is analyzing. And this network of activities is the background that our background database offers compared to the foreground of the end product. Linking all of these datasets together enables us to assess impact using many different potential measures. And so here, for example, using the IPCC 2021 method, we get an estimate of the climate change impact for this product. And specifically, this score excludes biogenic carbon flows. That's the carbon that the bamboo plant is turning into biomass through photosynthesis. But there are other IPCC methods that include biogenic carbon flows. Specifically, inputs are counted as negative and emissions are positive. This is also called a -1+1 approach. And so in most cases, these should cancel out perfectly if you do an analysis that goes all the way from the beginning to the end of life for the product. But if you ever use this -1+1 method that includes biogenic carbon, or if someone else uses it and presents the results to you, you should compare those results to the ones that exclude biogenic carbon. And if the results are not the same, you should be skeptical and figure out exactly why they are not the same. There are a few cases where a difference is correct, but there are many where it would indicate that there's a mistake somewhere in the supply chain calculation, or you have an incomplete analysis. So for example, if we include biogenic carbon flows for the bamboo pole dataset, we get a very different score for its climate change impact. And in fact, it's negative. And so as bamboo producers, we might be delighted to see this, but remember, we need to be skeptical if results differ from the other method. And so I wonder, can anyone tell me why the score is negative here? Does anybody have any ideas? You can just unmute and say something if you've got some input here. Nobody knows why the score is negative? I'll tell you if you don't know, but if you have some ideas, this is good too. So the score is negative because our analysis does not include the end of life for this bamboo pole. We know the pole is going to disappear at some point. It's not going to last forever. And it could be misleading if we measure its impact, assuming that it will. So it's important to proceed with caution if you ever use these include biogenic CO2 scores. So in conclusion, these are the 3 takeaway points I want you to remember from this presentation. First, if you want people to know what the environmental benefits and impacts of your materials are, submit data to EcoInvent. Second, if you want to follow flows of carbon or other elemental flows through a bio-based products supply chain, you can examine the properties and the elemental flows. And then finally, check results really carefully if you are doing impact assessment, especially around biogenic carbon flows. So that's all. If you'd like to follow us on LinkedIn or subscribe to our newsletter, please follow these QR codes. And here's my email as well, in case you'd like to get in touch. Thank you so much for your attention.
Thank you. Thank you, Gabriel. Great presentation. We have some minutes, so if someone wants to make a question, please open your mic, or we will just keep them for the Q&A session at the end. All right, Hector, please go ahead.
Gabriel, just a question. Because probably many people don't know how to get to EcoInvent. Is this data publicly available, or what do you need to see this data?
No, the data require a subscription. There are a number of different subscription models depending on your use case, and you can find this all on ecoinvent.org. All the information that you would need to get a subscription that fits with whatever it is that you'd like to do with the data.
Okay.
Thank you.
Thank you.
All right. Once again, thank you, Gabriel, for the very interesting presentation. Please, it will be great if you can stay with us for the Q&A session. And our next presentation is Hector, that is already ready.
Right.
So please, Hector, start your
I'll share the screen
sharing.
now. Yes, let me just see where we are. I don't think I have any videos, so you give me the heads up.
No, it's perfect. Thank you very much.
Perfect.
It was mentioned before, Hector is member of the Construction Task Force of INBAR. He's also Bamboo Ambassador for the World Bamboo Organization and Vice Chair of the Natural Materials Group. We have been collaborating for over a decade now in different projects, and now on his position as Senior Lecturer at the University of the West of England. And is also, on top of that, also founder and CEO of Amphibia Base Limited in the UK. So Hector, please, the floor is yours.
Excellent. So many titles, isn't it? We accumulate titles and do many things in the background. Anyway, thank you, Edwin, for the introduction. And yes, this is actually part. Well, this is what I'm going to present today is a little bit of a results from all that wonderful collaboration and that wonderful work that we do with at our places of work, but also with INBAR and as part of the task force for bamboo construction, which, part of our work at that task force for bamboo construction is to disseminate knowledge and to raise awareness of how you can better use bamboo, and and what is it that the last developments on bamboo research also. But anyway, so what I'm going to tell you about is a little bit about this latest work that we have been developing, and it follows quite nicely from what Gabriel was saying in terms of LCA analysis, because what we are actually saying is it's really good to do the LCA analysis. We do need it. We do need to use it, but perhaps we need to also look at other impacts that construction and the use of materials have in construction and in the planet, in the global context. So yeah, you can see there some of the authors of a paper that we published recently. You got Fernando Speciale from University of, well, Politecnico di Milano, Edwin, who is here too, and we got Ken Harris also from University of Pittsburgh. So let me just tell you then why creating a framework of regenerative construction and why using engineered bamboo. So I guess the clues are in the title. So we need to look beyond sustainability, and that's what regenerative construction, regenerative design is about, is looking at not doing harm, because being sustainable is not enough. We need to look at how we can enable living and human systems to survive, thrive, and co-evolve, and how to repair the damage that we have caused already. We know that human activities have created a huge damage on the environment and on the planet. And we have, in construction, we have focused a lot on financial gain. And lately we have become a little bit carbon centric. So everything is put in terms of carbon. So we need to look at perhaps at construction as a systems in a systems thinking way, and that means, and that we have done, is looking at construction in a systemic way, and at the impacts that construction have in a systemic way. So basically, it's something similar. To simplify it a lot. We have developed a framework that considers human impacts, social impacts, natural impacts, financial and manufacturing impacts, and that goes along a framework created by Jonathan Porlet, which is called the five capitals system, or the five capitals framework, which you can read more if you read the paper, and I'll share a QR code at the end where you can find more information, but you can read a little bit more to know what it is. But you probably, from the names of each of these labels, of these impacts or capitals, you might realize the importance of each of those factors, So what we have done, and what we're gonna explain a little bit more in this presentation, is how we develop that human, social, natural, financial, and manufacturing scoring system, which is very alike a food labeling system in places where if you look at some food products, in some places you will find a food labeling system that says, oh, this contains this much of sugar, this contains this much of fat, salt, carbohydrates, etc., etc. So we are doing something similar, and we are doing something like that for a series of systems that we develop. I'm going to concentrate in only one system, but I'll show you more in a few minutes, where we have used, for instance, mainly fast-growing materials, and we have created a whole system of construction, and we have evaluated those five, or we have evaluated those five impacts on each of those systems. This is one of them, a fast-growing bio-based system, a timber and bamboo bio-based system, and a passive house bio-based system, because we wanted to compare those, these systems that we have created with the best sort of standard available, and with traditional construction, at least in the United Kingdom, where of course we have seasons and the way we build is a bit different. You need more insulation, and it's a bit of a different system. So what I'm going to be showing you in this presentation is a problems and solutions approach, and the solutions, of course, address systems. But then let's start with the first problem. We do know that the construction industry has a high embodied carbon footprint. And when you look at, at the global emissions of construction, we know that construction emits about 40% of all global CO2 emissions. And we are very dependent and almost addict to two materials, cement and steel. Steel and cement account for 50% of all global CO2 emissions. So that's very concerning. And you can look at that graph where you can see how reliant we are on those two materials. And that creates a problem to the future, of course, because as we are becoming much more efficient in terms of the use of energy, and we are decarbonizing electricity across the world, the problem in the future will be materials, building materials, the materials we use for construction. Not so much the energy, but the materials, the embodied carbon on those materials. So, of course, a solution to that is using bamboo, and engineered bamboo is of course a way forward. And this is a work that we have done actually with Edwin here and with Guillaume at ETH in Zurich. And we looked at, what happens when you build with round bamboo, and what happens when you build with engineered bamboo in one story or in multi-story buildings. And we compared that to brick construction and to concrete block construction. And of course, the values are unsurprising. If you build with a single-story house with round bamboo, your carbon balance is negative, and of course, you need to listen. You probably heard from Gabriel. You need to be careful with what the boundaries and how we analyze those carbon emissions. But you can see from a comparison there how the single-story house of round bamboo has the lowest carbon emissions. And if you use engineered bamboo, you also have a very low carbon emission and almost, negative carbon emissions if compared to brick and concrete. And of course, it makes sense to use engineered bamboo in places where bamboo doesn't grow, because you're not transporting air around the world. You're transporting a ready material to be used in construction, and a material that has been engineered. So you would say that using engineered bamboo is a no-brainer. So we can, because you can engineer the material to respond to the structural needs that you have. It has a low carbon footprint. And again, as I was saying, if we transport it internationally, you won't be transporting air as it happens in a round cone of bamboo. It's mostly air, really. So the problem really that we have with engineered bamboo, and that's, I'm doing a quick recount of some of the experiences that we have had on developing engineered bamboo products and making them competitive. We realize that, at present, doing something with engineered bamboo is very expensive. And if you compare the prices of engineered bamboo for structural products, they're about 5 times more expensive than a cross-laminated timber product, which we are using more and more in, say, in Europe, in the US, and other parts of the world, where these prices for, I think this is 2024, so a year, you need to adjust them now for inflation. But the prices more or less are 5 times more expensive for engineered bamboo products. So that is a big problem, not having a material that can be competitive with other bio-based materials available. And we know that bamboo has many, many benefits. So in terms of that, something that we have been doing is we have done some innovation with engineered bamboo, and to do that, we realized that you don't need engineered bamboo products that are only bamboo. You can mix bamboo with, say, timber of low grade, and timber or wood species to which we don't add much value. Because at the end of the day, a lot of what we need in engineered products, if you have a strong material like bamboo that has been laminated, that has been engineered, really what you need is something to fill the gaps, and to distance the main load bearing layers on an engineered bamboo product. And we did, we've done a lot of work on this. We have done all the mechanics, all the engineering of this. You can scan the QR code to find more, or just Google my name and find some of those papers. So we have done all of that to demonstrate that you can have a material with high mechanical properties that can be competitive and that can have a very low carbon footprint. And this is along the lines of developing technically, environmentally, and economically viable products. And you can see from these results of that research how, if you compare to the products that I mentioned, the cross-laminated timber products of 5 layers, so that's the CLT5. If you compare the modulus of elasticity of a CLT of a 5-layer CLT product with timber and bamboo hybrid product of 5 layers, we can achieve higher modulus of elasticity with a cost difference, and this is a cost difference that is, I think, is about 10% higher. So and then when you analyze the CO2, and this is not including end of life, you can see that biogenic you can see that carbon footprint is much lower too. Of course, is 15, so it's a factor of 15, 1.15, which is much higher, but is still within manageable cost in construction. You would say it's probably a client will pay 10 to 15% more for a product that has more benefits in construction. And of course, that depends on what type of structural construction we're talking about. So from these, you can see that we have a material that has the potential of being structural, of being feasible for structural applications, also economically viable, and a material like those timber bamboo engineered products that also provide us with a low embodied carbon footprint at least from the manufacturing perspective. We haven't done all the life cycle analysis, but we know that from the embodied CO2, when you compare it to other products, we have a very low embodied carbon footprint. So then we need to move forward and think not only of materials, but also of systems. How do we integrate those engineered timber bamboo products into real construction systems? Because standalone products won't sell themselves, and I have gone through a very long journey of finding and creating business cases for these type of products, talking to many people in industry, and we do know that you require systems. So you require materials that can play along with building systems, and that's what we have done with those systems that I showed you at the beginning. So we have created what we call a fast-growing bio-based system, which includes walls, floors, and roofs, which use materials that take between 5 months, like hemp, and 6 years, like bamboo, to mature and be ready for construction. And with the right processing and the right detailing, you can have them, you can use them for long-lasting construction. And that's what we have done there. We have done the same for hybrid timber and bamboo systems, where we have, for instance, we have a high, a very thick wood fiber insulation, and we have a timber bamboo panel that provides the structural integrity, with other materials that provide the internal lining and the external cladding for those products. And of course, comparing with best practice, with Passive House standards, we compare that with a bio-based, fully bio-based, mostly timber-based construction system, and also we compare we compare these systems to a traditional construction system, at least for the United Kingdom. So let me show you one specific system and the results from our work, and how the framework, what the results that we got from the framework are. So this is a timber bio-based system for domestic construction. You can see there, number one is our structural component, the timber and bamboo material, the timber and bamboo product. Then you have that thick wood fiber insulation, of course, that's separated by a breather membrane that is necessary in this type of construction. It's necessary in these latitudes. And then you have internally, you have the plasterboard, that is a hemp-based product, and externally to the right-hand side of your screens, you will have the cladding. And the cladding that we use here, it's actually, I just realized that there is a mistake there. But the cladding, no, it's external wood cladding. No, that's completely correct. So, and we have, for instance, the other one is a fast-growing bio-based system with an engineered bamboo I-joist with hemp flax insulation, hemp plasterboard, and a thermally modified bamboo cladding in the exterior that was provided by Moso International, a company that produces Moso products that distributes Moso products in Europe and internationally. But let's have a look at that. I mentioned that we have that framework, and one of the impacts that we looked on that framework was carbon footprint. And you can see, when you compare, say, a timber bamboo product to the traditional system or to the passive house system, you can see that there are big differences in between. Well, let's just look at the traditional system and the timber bamboo product. You can see that we have a much lower embodied carbon footprint. This is including biogenic CO2 from A1 to A3, and that happens in wall assemblies, in floor assemblies, and in roof assemblies. Of course, the amount of materials that you use in those assemblies are different, so you can see the differences there. And from that, what we have, this is sort of a summary of the results. You will see a lot of what we have is graphs like these, where we compare all the results that we have. But when you look at the manufacturing impact, the natural impact, the financial impact, and that's cost, the human impact and the social impact, you do realize that the engineered bamboo system solutions do have the best scoring in terms of all those of all these parameters. So we are looking at parameters, not only carbon, which was the only one that I showed you there, but we are looking at a whole compendium of factors there. And of course, this we can extend more on that, but it's probably best if you have a look at what we have published, because at the end of the day, what we're looking at the future, and the future is probably those multi-story engineered bamboo buildings like this one in China by Professor Yang Xiao, which has been built recently. It's a six-story it's a six-story bamboo building using engineered bamboo, and it demonstrates that it's possible, and with good detailing and good specifications, we can get there. So in conclusion, I probably have taken more than the time that I have been allocated, but these are the conclusions. But basically, what I wanted to tell you is we should look at construction in an integral way, and all the impacts that construction can cause from a human perspective, health and well-being, from a cost perspective, from an environmental perspective, looking at biodiversity and CO2 footprint, and from a technical perspective also, which is that manufacturing value that I was telling you about. If you want to know more, this QR code can give you more information of the work that we are doing, and I think that's all that I had. Sorry for taking a little bit more of time than I should have.
Thank you, Hector. No problem. We are good on time. Maybe we can get a quick question now, and then we leave the rest for the Q&A. No one? Okay. So let's move on, and it's a real pleasure for me now to invite Kevin Liu from INBAR, dear colleague, been collaborating in many different levels, and especially this work that she's now leading on life cycle assessment of engineered bamboo that Kevin will share today with us. We didn't introduce her properly, but she has a long experience working at INBAR as project manager, and is also a conveyor for the ISO TC 165, the working group 12. So she's been also very involved in the development of all the ISO norms that with support of the Construction Task Force from INBAR have been developed in the past decade. And now she's also taking the baton and working on life cycle assessment of materials and buildings. And today, Kevei will share with us her work on life cycle assessment of structural glue laminated bamboo. Kevei, please, the floor is yours.
Okay, thank you. Thank you for your introduction. I will share my screen. Can you see my screen now?
It's not yet in full screen.
Okay. Right now, it's okay.
That's good.
Okay, so this actually I organized this INBAR webinar for 6 years, but this is the first time for me to deliver presentations to all the participants of this seminar. So it's my great honor to introduce our latest research work, life cycle assessment of the industrial production of structural glued laminated bamboo on behalf of all the team members from INBAR, Tsinghua University, Green Zoo, Eco Events, as well as Edwin's former affiliation, ETH Zurich. So our latest work has been published in the Journal of Cleaner Production last year. So if you are interested in this work, you can download the full article from Web of Science. And today I will introduce the following 5 aspects of the contents. As we know, glued laminated bamboo is one of the most commercial products used around the world. In recent years, it has been used in permanent structures, as Hector showed to all the participants here. Actually, in China, Professor Yan Xiao already constructed one glued laminated bamboo, combined other engineered bamboo products into 7 stories. So it really has a great potential for commercial markets. So as we know, bamboo absorb carbon dioxide by photosynthesis, and when we harvest them into bamboo kernels, we could produce them into bamboo strips after sign compress and lamination technologies. They could be produced into structural glued laminated bamboo, which can be used as beams or corners in permanent structures, which can last more than 50 years. So bamboo in the forest, when it grows, it can absorb carbon dioxide to store the biogenic carbon in itself. And during the manufacturing process, because of the inputs of other materials and energies, it also emits carbon dioxide. And when we use them as permanent components in structures, the biogenic carbon can be stored there until the end of life of the structure. Depends on the different treatment of the products. The carbon storage and carbon emission is quite different. So for this process, we really want to know how carbon cycled during the entire lifespan of structure. And we also want to quantify how much carbon can be stored per cubic meter, one function units of these products. And also want to quantify how much carbon will be emitted during the whole manufacturing process. So currently, we already get the life cycle inventory of these products. And Edwin and I, we are preparing the submission to Eco Events. We are working very closely with Gabriel Smith and Olivia currently. So let me introduce the system boundary of these products for our research, we set up cradle-to-gate boundary for it, including 4 phases. One is bamboo growing in the forest and bamboo harvesting. The third one is production of fine plant bamboo strips, and as well as the final products producing. So because the boundary is from the cradle to gate, we also exclude some carbon emission. For example, so the end of life carbon emission, if we burn those structural components at the end of life, we cannot calculate currently at this moment. And we also exclude the land use change before bamboo planting, and we exclude the carbon emission due to the burning of bamboo core products and the biomass fuel in the factory, because we treat them as the balanced carbon. So we actually, for this basic research, is really very tough. It's also the first time for me to carry out the detailed field investigation and experiments in the factories. We spent over 1 year, took 3 field investigations to 6 manufacturers, interviewed 5 enterprises for invalidating data. So let me introduce how to calculate the carbon storage of these types of products. Based on the calculation method developed by CIN for those timber products, we developed its own equation to calculate its carbon storage, and according to its own characteristic and considering material loss in sanding and sawing processes. You may notice that there are lots of the parameters we need to determine during the experiments and the records of manufacturing. So we need to find out the density of this products, the moisture content, density of 2 types of adhesives for both hot and cold compression, as well as the weights of adhesives for hot and cold compression, and how much bamboo strips we need to produce 1 single panel, and how many panels we need to produce 1 cubic meter of these products. So first, we measured 72 samples of 4 sections, which cut off from commercial products, from those purlins, rafters, or corners. And we can get the average density of these products is around 680 kilogram per cubic meter, and the moisture content is 7%. And second, we measured 600 bamboo strips to get the applied liquid adhesives per square meter on bamboo strips for hot compression. And for the cold compression, the data we get from the manufacturing record. And we also need to get the solid contents of 2 types of adhesives by experiments in the factory. Let me introduce the entire manufacturing process. You can see from this slide, actually there are almost 30 different manufacturing processes required for the production of these products, from the bamboo growing in the forest, cut off them and cutting them into bamboo cones and splitting them, and after rough planing machine, we set them into the caramelization boiler to get rid of starch. And after 2 turns of kiln drying, and we processed them into the fine plant machine and have the automatic selection. And we could get the fine plant bamboo strips. So fine bamboo plant strips are also provided to produce other bamboo products, not only structural glue limited bamboo products. So once all the fine plant bamboo strips transported to structural glue limited bamboo processing factory, we need to prepare the finger joint hooks and gluing them and assemble them into the single panel and cut off into certain lengths. And we can have them under the hot compression machine and sewing them, sanding all the single panels, and we will use the coat adhesive to compress them into structural components. So after the coat compression, sanding them, sewing, and to drying, as well as the treatment for anti-mold and corrosion, also paint some kind of the acid, then we could package to transport them into the construction sites. So after we understand very well for the entire manufacturing process with relevant machine or facilities, we could get the detailed inputs for energy and materials. So we used the methodology of calculation of carbon emission recommended by IPCC. This is the most popular methodology to calculate the carbon emission of all kinds of the products. So this kind of methodology needs 2 types of data. One is activity data we got from the entire manufacturing process. They are primary data. And another type is emission factor. We use them from EcoInvent database. So you may notice that there are 2 types of inputs for the entire manufacturing process. One is energy, including electricity of all the machines, natural gas. In some factories, they use natural gas for the hot compression process, and diesel for transports and bamboo poles sewing, as well as some kind of the bamboo core products. In many factories, they use them as biomass fuel for the steam boiler for caramelization and kiln drying. So there are some also some types of the material inputs, including bamboo itself, and 2 types of resins, preservative and acrylic resin. So let me introduce a little bit about how to connect and the calculation of the quantity of consumed electricity, because for this product, more than 70% of the carbon emission caused by the electricity. So we need to carefully check with each process which required to use machine. For example, for rough planning, we measured 12,000 strips. We measured 12,000 strips. They need to deal with 12,000 strips by 9 hours, by 1 cubic meter products only needs 4,200 strips. So we need to have the equivalent calculation for each step. We really have a very long list to calculate them, and all the detailed information provided to the journal appendix you can figure out. And to produce the mass flow of this product is also very important for us to understand how bamboo, the width of bamboo, and the moisture content change during the whole process. So it's very important for us to use this manual flow to produce the life cycle inventory. And as I introduced, we also need to connect relevant data of quantity of natural gas, bamboo harvesting, diesel, transportation, as well as all kinds of the material inputs. So after the completion of getting all the required data, we can calculate the carbon storage of these products. You can see these products, 1 cubic meter can store 1,140 kilogram carbon dioxide equivalents. And we also could get the life cycle inventory for the details, including core products, fuels, and material inputs for the production of these products. So we use uncertainty analysis of Monte Carlo simulation based on the triangular distribution and uniform distribution. And we also use emission factor of the version of eco-events 3.10 for this journal's calculation. Actually, we could use the latest version 2024. The carbon emission of the products will decrease because the electricity emission factor decreased as well. So after the Monte Carlo simulation, we could get the mean value of these products produced in Jiangxi province, which located in the central China. And the average carbon emission is around 460 kilogram carbon dioxide equivalents. So do you remember that it can store 1,140 kilogram carbon dioxide? It means that from the cradle to gates, the carbon storage is more than twice of carbon emission for these products. It really have the great potential to help us reduce the climate change. We also analyze the phase contribution to carbon emission of these products. You may find out for the fine plant strips processing, it accounts to 60% of the total emission, depends because the consume of electricity. Also, in structural glued laminated bamboo processing factory, it's involved all types of other energy and material inputs like electricity, natural gas, adhesives, preservative, and acrylic resin. It only accounts for 33% of the total carbon emission. And from the top 10 process contribution to carbon emission, you can find out the rough planning, kiln drying, fine planning, and selection of trips, and 2 types of the reason they list ranked the top 5. So from the perspective of how to reduce carbon emission, we could suggest manufacturers to consider to reduce carbon emission from the top 5 processes. And for the journal, we have 3 very interesting discussions. The first one, because I don't know whether you know very well about the distribution of bamboo resources in China, because there are lots of the provinces located in southern China. They produce the most bamboo, for those provinces, they belong to the different power grids. So according to EcoInvent's database, they divided into divided the electricity provided into different regions. So we combined electricity provider with different bamboo resources area. We have the analysis for the production of these types of products in different regions, in central, in east of China, as well as the average one. The second discussion, because the higher consume electricity, we consider whether we could use innovative heat and power cogeneration technology, which is popular, widely used in those countries, in European countries. So this kind of the technology can really help the carbon, reduce the carbon dioxide emission. So by using heat power cogeneration, the carbon emission can be reduced from 460 to 150. So emission by electricity is only 23 kilogram carbon dioxide equivalent per cubic meter, or counting only 14% of the total emission. So in the future, we can really recommend manufacturers to purchase electricity produced from local green energy sources if they have the needs to reduce the carbon emission of their own products. The third discussion, we calculated the additional transportation after the factory gets. We assume this kind of the products can be sold to different cities of different countries around the world, to the USA, to in European countries, the Philippines, Australia, UK, Japan. We compared the contribution of road transportation and sea transportation. So we assumed we transport this kind of the product from the central China to Beijing. The distance is less than 2,000 kilometers. We transport it only by road transportation. You may find the results is very interesting, because the carbon emission to transport this product to Beijing is the highest one. Compare, we assume transport them into any other cities around the world. Even transport it to Washington is also lower than transport to Beijing, because So carbon emission factor of sea transportation is only 1/10 of which of road transportation. So actually for carbon emission life cycle assessments, there are lots of the items we can figure out. So I will have the conclusion for the research we have done. We developed the methodology to calculate the carbon storage and carbon emission of these products. And the most important thing is we collected the primary data, reliable data of life cycle inventory for these products by using experiments and field investigations. And we also have the calculation of carbon storage and carbon emission for these products. Have carried out 3 very interesting discussions. So currently, we complete this work by the end of last year, and this year we are mainly focused on the research of comparative analysis of carbon emission and carbon storage of glued laminated bamboo structures compared to other 3 traditional structures like glued laminated timber structure, steel structure, as well as concrete structure. We are looking forward to have further discussion with all of you. So this is my email email address. If you have any questions on life cycle assessment for engineered bamboo, or you have any question on international standardization, you can also write email to me. So Edwin, I complete my presentation. So hand over to you.
Thank you, Kevin. Thank you very much. All right, I see Gabriel, maybe Hector, if you could join us back for a moment, and then we can have a short Q&A if we have any present questions from the audience. Right, so if anyone has a question, please open your camera and your mic and go ahead.
Hi, I have a question for Hector.
Yes, go ahead, please.
Yeah, I found the presentation very interesting, but I was wondering if in the research it was also assessed the water footprint and water scarcity impact of the timber bamboo product, in addition to the carbon footprint.
Excellent. That's Michelle, isn't it?
Yes.
Yeah, Michelle, that's a very good question. I realize I could have told you a little bit, could have told everyone a little bit more about those the different parameters that we analyze in terms of that, say the natural impact. So yeah, for the natural impact, we did look at water use for the production of the products. We looked at drought, flooding, and other stuff that is, of course, important when designing or when using those materials, and what the impact on biodiversity of using those products is. So yes, we did consider water.
Thank you. So I was wondering if in the case of, for example, carbon emission, the results were also competitive with the other materials that we were compared, or if
so. There will be a bit more of detail on the paper. But yeah, we do. So we intentionally chose materials with like hemp with a very low embodied carbon. I don't remember what the the figure is. But we do, for instance, for that fast-growing system, we did choose on purpose. We did choose materials that grow very quickly, absorb carbon in a very short period of time, and that if you lock it in construction for long periods of time, have a super advantage in terms of carbon footprint. So,
Okay.
so yeah, I could, if you're interested on these, you could email me, and I can share more information. Or if you are interested on a particular topic and want to do a little bit more research on that, we can discuss, because this is of course ongoing work, and I have some people helping out also with the research. We have developed the actual models also, because we wanted to make sure that this was buildable. So we build sections of that, and and we use materials that were available in the market. So I mentioned products from, say, Moso bamboo, but other companies also that produce those hemp products, and of course the timber products also. But yeah, by all means, if you want to email me, please
Yes.
do, and we can have a more extended conversation on the particular
Topic.
data and figures that we use.
Yeah.
Yes. Thank you so much. I will write an email.
Please do. Thanks, Michelle.
Great. Okay, we have one question for Kebe on the chat. I'm trying to interpret. And they say, is necessary that the bamboo is grown and processed in the same country where it's used? From your analysis?
Actually, as I introduced, I invested many factories for, because there are two types of the factories. One is the fine bamboo strips processing factories. So actually, I visited many of them to get the average data for those machines, and so in efficiency, how much bamboo strips they could produce. And for the final products processing factories, I invested one, and also interviewed another two to validate the data in order to get the reliable life cycle inventory data for this product. So the process is really very tough, because it's really to figure out data from manufacturing factories.
Yes, definitely.
Can I make a comment? Can you hear me?
Yeah, go ahead.
Thank you. Thank you for all your presentations. They're very interesting. I am located in Ecuador. I work with a company that produces actually bamboo laminates. That was actually trying and still produces teak wood and composite walls like the one Hector presented us. And we find out specifically in our country, which is a country that has all the resources. We do have a big production of bamboo. We actually, I believe, export bamboo to China, which has a high demand on bamboo from all over the world. And in this small scale factory, we try to produce the bamboo flooring laminates in order to do the composite structural beams and also panels for flooring walls, etc. But we still find out that due to scale, production scale, and perhaps efficiency or other factors, China still is able to bring these panels to Ecuador with a lower cost, even though we have all the transportation, all the externalities that Professor Kebe presented us, and is amazing. We are not competitive, really.
Well,
That's the reality.
you try to compete against the largest producer with the more than 10 years of experience and development of industry is in anyone is very challenging. So in any industry. So that's more an industrial fact that China is ahead on production for decades of everyone. So you can the more mature is your industry, you can lower your cost, you increase efficiencies and everywhere. So it's a matter of fact. I saw two questions, sorry, Hector, just to answer the land a lot on my field. I will take the moment to reply because it's asked about the fertilizers and the species. That was not presented today, but this work we have done before, and fertilizers is something that it is very variable. So every field is different. So in the datasets you will see in EcoInvent, for instance, we have an input for fertilizers that can be 0 or something. It depends on the production process. So it's not something that you require. There are some places where they will fertilize, but most of the places will not fertilize. And regarding the species, there's not a big difference in terms of carbon footprint. So anything that is related to emissions, the species will not play a significant role. The only difference that you will get is when you start looking at things related to land use demand, because of the production volumes that you have from different species. There's where you will find a difference. Hector, please.
Yeah, I just wanted to sort of reply to Javier because I I've been there, and that's why I presented a little bit of that concern that we have from developing materials that at the end of the day are not competitive when you look at the prices that are in the market, and Chinese manufacturers also know that they can compete with some of those with those structure engineered products. So I would say differentiation is a way forward. Let's not do the same that our Chinese colleagues are doing amazingly well. So I think we need to understand the material very well and differentiate so we are able to compete, because otherwise it's very difficult. If you produce the same products that suppliers in China are producing, is going to be impossible. The industry has also subsidies and is well supported by the government, which doesn't happen in countries in Latin America. I don't know if in Ecuador, but we have had the experience in Colombia that probably over the last 20 years, companies that have developed that have established manufacturing facilities for glue laminated products using the species available in Colombia, they have all failed. They have all gone into bankruptcy because the products, of course, were not the right products, I would say. So differentiation is a big one, and looking at your market, because is a chicken and egg situation, and probably you know that very well.
Alrighty. Thank you very much. I think we are a bit over the time. We had some questions. Once again, thank you to all of you attending. I think we have a new record in attendance for this session. Thank you to Rylem also for supporting us, and really my heartfelt thank you to all the presenters. It just left now to invite you next week at the same time. We will have another session in this online seminar. And I hope you all have a good morning, afternoon, and night for those joining today. Okay, everyone. Thank you very much, and see you next week, hopefully.
Edmund, I think I suggest that we have a group photo. And for the presentations, I think you can go to INBAR's YouTube. We will upload the record tomorrow. You can repeat to Lei to see this video,
Yes.
all the presentations.
All the presentations and from previous online seminars are also available in the YouTube channel from INBAR.
Yes.
So you can also see the previous work presented. Do you make the picture, Kevin?
Yes. So
We have many.
maybe.
Okay, everyone, please open your camera. We can have a group photo. So, okay, just wait a second.
Is the photo done?
Okay, it's done. It's done. Okay.
Thank you.
Thank you.
Thank you.
Thank you.
Bye, everyone.
See you next week.
Thank you,
Okay.
Kawai. Thank you, everyone.
Bye, everyone.
Thank you. Bye bye.
Bill,
Have a great day.
Captain,
Thank
everyone.
you.
Luisa.
See you next week.
Bye bye.
Bye-bye.
Thank
Bye. See
you.
you.
Hi, thank you so much.
May I God bless you.
Thank you.
Thank you.
Thank you.